Alright, it seems that we're live. I'm gonna show myself. There I am. And alright, it seems like everything's working. So today I want to do at least the second of these 3 exercises from the end of chapter 8 of the Rustling book. And pretty much it's to convert strings to Pig Latin. And so the first consonant of each word is moved to the end of the word and A is added. So first becomes erstfey. Words that start with the vowel have hey added to the end instead. Apple becomes applehay. Keep in mind the details about UTF-8 encoding. Alright, so I want to do this first, and I want to give a brief, I suppose, comment on how I was doing it before. So when you look at this code, right, this was for the first problem. Given a list of integers, get the average, mean, and mode. Average, median, and mode. And I felt like there wasn't really a whole lot of order to what I was trying to do during the stream yesterday. Right, I just sort of was going along and solving it as I usually did. I don't think I was explaining extremely well what I was doing. So I think today I'm going to try to first give a pseudocode description of what I'm doing, and that way we can, or at least I can, hash out the formal logic of what I'm trying to do and how I wish to solve the problem, and then I'll go along implementing that pseudocode and going from there. And I'm sure when big pieces of trouble come along, where some syntax thing that I gotta figure out, then it's just gonna, it's not gonna seem as deliberate as just simply implementing pseudocode, but I want to give it a shot at least, so that perhaps the stream, like I said, seems more deliberate and not me all over the place and hard to make sense of. So alright, I'm just going to delete all of this. This is just exercise, right? I'm not really all that concerned about it. So I'm just going to get rid of it. And we'll move on to the next one, which is Pig Latin. So first thing is I want to give something concrete for a test bench. So we'll say let, we won't make it mutable because it shouldn't change. We'll let test bench equal, and I believe we take in a string. Right, so we're going to say, because we want it to be UTF-8, so string new, and alright, no, we want from, and then we'll just do hello. Put a comma in there, world, and exclamation point. And so let's try to figure out how to get the logic that will convert this into Pig Latin. So, alright. And this is going to be a fairly simple case, because in this case we don't have to implement the case where the word starts with a consonant, right? It's hello and world. They're both consonants. We don't have to implement the case where it starts with a vowel, sorry. Maybe we should add a word in here. That does start with a vowel, and so So let's just say, hello, amazing world. And this right here will let us, it'll encourage us to check the case where the boundaries of the word is not just white space, right? So the boundary for amazing is white space on both sides, as opposed to world, which is bounded on this side by an exclamation point. So we have to be able to handle that case, and also handle the case where it starts with a vowel instead of a consonant. So, all right. Now I want to describe the logic that I want to do to accomplish this. So just thinking about it, the first thing we need to do is split test bench into separate words slash, well, we'll call them tokens, into separate tokens. So we want to separate the tokens based on whether it has numeric characters. So we'll just consider everything that, sorry, not numeric, alpha characters, so alphabetic characters. So anything that is fully composed of alphabetic characters, we're going to consider a word. Although, what if we had this, you know, something with a dash in it? Then we would want to consider that as part of a word, wouldn't we? So I'm just looking at my keyboard right now, just trying to look at all the special characters on it, at least on this top row, and we'll just consider that. Into separate alpha plus dash tokens. Alpha including dash an underscore, I suppose. No, let's, well, I suppose I'll include underscore. Actually, I won't. Well, I'm just going to include dash. That's it. Including dash if it's in the middle, in between two alpha characters. I'll put this over here. So after that, we want to, so once we have the separate tokens, perhaps in an array, split test bench into separate alpha tokens and store in vector v. All right. So that's number one. Number two. If beginning of actually what we want to do, because this exclamation point is going to be its own token separate from world, right? And so I suppose we'll remember that when we say alpha tokens, is that they're not specifically all composed of alpha characters. It's simply the lack of alpha characters starts a new token, if that makes any sense. So after this, we're going to check if the token is entirely composed of alpha plus dash. Well, actually, we're just going to say not entirely composed of alpha plus dash. And we're going to do this, we're going to loop over all tokens, right? So this is actually going to be 2. This will be 3. And then, so we're going to loop over all tokens. And then I suppose we'll call this 2A because it's within. So if the token is not entirely composed of alpha plus dash, then I guess I'll say 2A1, then pretty much ignore that token. And continue to next iteration. So now we're going to go to 2B. So now at this point we know that the token is a character we want to operate on. It's something that we want to make into, well, we want to translate from English to Pig Latin. So if first letter of token is consonant, this will be a 2B1. So if the first letter is a consonant, then we take that token, so then we remove first letter C from token 2B2 is we append C plus A, was it? Append dash plus C plus A to token. So for every token, okay. So then after this, we're going to do to see if first letter of token. So I'm trying to think of the case, let's say if you had a dash in front, right? This would be similar to this, right? It doesn't make any sense, but it would be similar to this. Or let's say this were at the end. And so we should be able to recognize this as being composed, this being composed of two tokens. Amazing and dash in the same way, and dash space in the same way that this is composed of two tokens. World and bang. And do you want us amazing ass world? Nah, we'll keep it PG, I hope. We'll do it like this. So if this were Pig Latin, then we'd put this. Oh, no. Because it's Pig Latin, I think the vowels are different, right? I'm not going to worry about these edge cases. It's not that important. So I'm just going to consider something like this to be composed of two tokens, but something like this to be composed of just, this is just all one token. And then you'd have to put A over here, or rather, if this were like, I don't know, smazing, then you'd have to put this at the end here with say. I'm not gonna worry too much about it. And if I'm not gonna worry about it, then I'm not gonna worry about it. So okay, we are really just going to deal with only alpha tokens, and so this is going to be two separate tokens. Yeah, I have decided it's too much work to consider this all one token. So we're just going to consider this. Because if you think about it, if you had this case, smazing, what are you going to do with this? Do you ignore it when you put the say at the end, or do you want to put two dashes, right? Because we're going to append dash whatever character in A. So it's too much. I'm now over it. So, all right. So if the first letter of the token is what is it? We already did consonants, so we want a vowel. Then we do Then append dash fay, was it? To token. Oh, hey. And then after this, we want to, because we're going to do all this for every token, right, inside V. So we'll say in V. And after this, we want to create a string out of all the tokens in V. So then we say concatenate all tokens of V. Just say print concatenation of all tokens in V. Alright, so this is our pseudocode. We're going to split the test bench into separate alpha tokens. So this test bench will have 3 alpha tokens. Actually you'll have 4 tokens. And alpha just means how it's being split. Basically, if there's whatever sequence of characters are only constituted by alphabetics characters, is pretty much how these tokens are going to be split. So it's going to be 1 and then 2, right? We're not going to just ignore white space. So I guess it's more than just 4. We're going to have 1 token, 2 tokens, 3 tokens, 4 tokens, 5 tokens, 6 tokens. And they're all split by the presence of alphabetic characters. Alright. So now that we have that, let's first implement number 1. And I'm going to label this 1A because there's 2 things here, right? Alright, so split test bench into separate alpha tokens. Alright, so now we want to split it up into its characters. I believe there was a way to do that. We're going to do this. Alright, so for C and blah.cars. So we're going to let a mutable vector v of type vector, and this is going to be type string, really. Equals vec new. Alright, and it's going to store each of these tokens as a string inside V. All right, so for every token okay, no, sorry, we're at step 1A. Split TB into separate alpha tokens. So we're going to iterate over the characters. So for C in tb.cars, is that the syntax? Yes. So first let's just print them out. Make sure we're doing things right. All right, cool. So that works. Let's I could just implement a function where it detects if the character is one of the 26 letters of the English alphabet, but I'm going to look it up. Rust, check if car is alphabetic. All right, alphabetic. All right, so that should work. Right, okay. So this is going to be how we separate it into tokens. So, all right. So now we want to get a slice okay, so let's do if C. All right, then we're going to let a mutable index equal 0. And we're going to enumerate this. And then we're going to make this into a tuple. And then we're going to call this I and C. Okay, so now we're going to know the index of the character for every character in the test bench. So if I print this out, so we're going to say ith car is C. Right, so 0th is H, first is E, second is L, third is L, fourth is O, fifth is space, so on. So now we know what I, the index, and C, the car, is in the test bench. So now we're going to, alright, there's that is alphabetic. So now we're going to test if C is alphabetic. Then what are we going to do? We're going to split, and we also want let mutable previous I equals 0, right? So in the first slice, we want to go from the 0th to the 4th, and then, well, really 0th inclusive to 5th exclusive, and then on the second one, on the second token, we want it to be 5th inclusive to 6th exclusive, so really just the space, and so on and so forth. And in order to do that, we need two indices, right? One is figuring it out from before, and the next one is going to be the current one that we're on right now. And so previous I is going to be tracking the previous index in which we found a non-alphabetic character, and the current I is testing to see if the current one is alphabetic or not. So if it is alphabetic, well, actually I want to do, does this work? Can you do this? So if it's not alphabetic is actually what we care about. So if it's not alphabetic, then we're going to push, so v.push the slice from previous I to I. Can I reference directly which car it is? I want alright, because I need to reference an index in cars, I want to have that as a separate variable outside of this. So let ch's, so cars, so let cars equal tb.cars. Then we're going to enumerate over them. And then we're going to push from cars previous I to I. Doesn't like that. This car is not an iterable. So let's just do it of I. So I can't index a certain, I thought we could. Can't index into it, but we can iterate over it. Can I do a .get? No. So we're going to go back to tb.cars. So now we're going to change it up. We're not going to do it like this. We're going to say if TempString. So we're going to let this be a string. We don't need to specify what it is. I don't know. So if it is alphabetic, we are simply going to push C onto this temporary string. All right, I think that's okay. And if it's not alphabetic, then we are going to first push this temp string onto V. So at this point, I don't think we actually need to define this. Right, it figures it out because of this. Borrow of moved value tempster. Okay. Can I simply push a reference to it? So instead of strings, we'll do references to strs. All right, I want to clone it. I don't want to create something new every single time. Right? Because what this is saying is that because TempString is being used in for all of these tokens, a reference to TempString is sort of invalid, right? Because, or at least borrowing it into V is invalid, because then we're going to borrow it. Like if we borrow it as a reference, then it's going to refer to at first this token, but then TempString is going to then refer to this token, and then it's going to refer to this token. And so for every single one, of these tokens at the very end, they're all just going to point to this stir. So that's going to be bad. That's if we do it as a reference, but if we did it as just a regular string here, this is saying that we can't borrow it because it's expecting to be changed here, and you can't do an immutable borrow if it's going to be changing elsewhere. So alright, so what's the solution to this? It's to, instead of borrowing it here, we're going to clone this string into V. So Rust clone string. And that still doesn't work. Oh, whoops. So I think this works. We're just going to clone the temporary string into V. So let's print out V. Makes sense. Alright, so at this point we don't care about the enumerate. We're not going to need it. Alright. So all we've done is say if it isn't alphabetic, then we push it onto it, and then we forget about what goes in between, right? And we don't erase what it was before. So now we're just going to erase what it was before. So we're just going to say let tempstir equal string new. Oh, this goes out of scope over here. So we're just going to do it like that. There we go. All right. So now when there's white space, it's going to prepend it here. What is going on with my phone? All right. So we are in a bit of trouble because we're checking. I could just push. So the problem is that I want each of the non-alphabetic characters to be its own token. And so the way to do it, simple enough, we just push here. We just, whenever we find a non-alphabetic, so let's say we had 2 in a row here, like this. And also we need to get rid of the previous. We actually got rid of that for some reason. We need TempString to be a new string, blah, blah, blah. Right. Okay. So this is non-optimal, right? Because we have an empty token, but we're just going to ignore it because if we append an empty string onto a non-empty string, it's going to end up being the same. So this is sort of what we want, where all of the tokens, so we have alphabetic and non-alphabetic tokens. All right. So now that we have that, okay, so we've split TB into separate alpha tokens and stored it in vector V. So it was pretty much, we did step 1 here. All right, so V is what we want it to be. Step number 2. For every token in V, all right, so for T in V, no, this is not Python. If the token is not entirely composed of alpha, we may want to store this as a tuple of both hmm. I believe because we pretty much have it such that alphabetic tokens are by definition separated from non-alphabetic tokens, we can just test if the first token, but we need to make sure that it's not empty, right? So okay, let's match. So okay. So we're first going to match t.get 0 Problem is that this is UTF encoding, right? So we can't index it directly and expect things to work out. Yeah, string is UTF-8. So we can't just get the first character like we were doing. I'm going to try to look this up. Rust get first character of string. Alright, I'm going to look up charat. Non-existent charat method. Funny. What does unwrap do? Alright. So because of this, I think it'll be useful to store this as tuples of type string and boolean, where the string is whatever it is and the boolean is whether it's alphabetic or not. So we're going to let mutable current bool equal false. So false, so current bool, the boolean is whether it's alphabetic or not. So we're going to assume it's not alphabetic, and then when we find something that is alphabetic, we're going to set it equal to true. Wait, is it this? There we go. Alright. And then after we push it, we set it equal to false again. And then because we've decided to create the new string for the current character, which is not alphabetic, we're just going to pretty much set it as false. And then it's only if it finds a alphabetic character is it going to set it true again. So let's say in this case it's going to set it true for this because there's alphabetic, then we set it to false directly after we push this. Then this one, it says, oh yeah, it's false, and then it goes back to here, right? But for this one, it's never actually set to true, right? It doesn't go into if C is alphabetic, and neither does this one, so it should be false the entire way. Ah, of course. I forgot. And of course, we need to actually print. Right. All right, cool. So now we have tuples of the string and whether it's alphabetic or not. So we're going to store them plus whether they're alpha in vector v. So if t, I think I had 1, all right, I think that's it. It's dot notation. So if it's not entirely composed of alpha, if t dot 1, because t is a tuple of string and bool, so 1 is the second of the two. So if t dot 1, oh sorry, if the token is not entirely composed of alpha, so if it's not t dot 1, then what do? Ignore that token and continue to next iter. All right, continue. All right, now we go to 2b. So I'll put this down here. Oh. So now we need to get the first letter again. All right. So this one we are going to loop over cars, I guess. So let's just do it. Let's bite the bullet. So if, let's just do a for C in t.0.cars So if it's a consonant, so if the first letter of a token is a consonant, all right, so we're going to take that guy's tip and we're going to say dot next dot unwrap. We are, in fact, absolutely certain that this is going to work out because this would actually return an option. We are absolutely certain this is going to work out because we've ignored the case that it's empty here. So we know that there's at least one character, one alphabetic character in here. And so we're going to unwrap it and we're going to ignore it. The option from next. So if oh, now I need a function for is consonant. Oh man. I'm just going to define it here. Fn is consonant of C, which should be car. It returns bool. So what is not a consonant? Well, sometimes Y, right? So AE so if C A or C is equal to B. Oh no, so A E. I'm gonna say val. we're just going to return this. C equal to I, or C equal to O, or C equal to AEIOU, and sometimes Y. We're just going to include Y, because why not? See what I did there? Alright. If is val alright. If it is not a vowel, then what do we want to do? Then we remove first letter C from token. I always forget the comment line. Alright. Then this is a string, right? So I can slice it. Oh, that's how I think. Wait, no. No, wait. Oh, man. Oh, man. How do I slice a string? Oh, man, I cannot. Alright. Alright, so we're not going to do this next unwrap thing. We're going to do for C in t.0.cars. So for C in t.0.cars, if first letter of token is consonant, we're going to enumerate this, and we're going to have I and C as the index and character C, and we're going to say if C is not a vowel. So we only care about the first letter for all this, right? So if I equals 0 and it's not a vowel, alright, so what we're going to do is we're going to have a temporary string. So let temporary string, which is a new string, if this temporary string, all right, so if it's, and we're also going to have let mutable temp character equal can I just do equal car new? No way. Yeah, that doesn't make sense. I'm just gonna put a 0. So if it's not a vowel, then we care about, alright. First, what do we want to do? We want to have this temporary string pretty much build our translation to Pig Latin as we're iterating over the characters in the original token string. So if the first letter is not a vowel, so in other words, if it's a consonant, then we're going to store it into the temporary character. So we're going to say tempc equals C, and then we're going to continue. Right, because otherwise of what we're going to do here. So in the other one, if the first letter of token is vowel, then all we have to do is append, right? But we want to first remove the first letter and then append the character A to the token after this letter C is removed. So in the built or in the generated temporary string, we want to remove this C first. But in all other cases, we want to tempstr.push C, right? And I'm going to actually put this as none. And I'm going to match this. And I'm going to do option of car. And I'm going to match this. Is this how you do match syntax? I forget. No, we don't want to match it here actually, sorry. We want to match it a little later. And we're going to put it as sum of C. Okay. Alright, so I want to just print this out, make sure things are looking okay. Hello, amazing world. Alright, that makes sense. Alright, so now I want to generate what it should be after here. Right, so amazing should be hey with a dash, and Ellos should be dash hey, and Earled should be Earled dash way. Right, so pretty much we're going to check if temp C is something, and if it is, then we add that something with an A, and if it's not something, we just add hey. So now we're going to match temp C is this how you do it? I forget the, oh right, yeah it is, we just gotta put the arms. So if it's something of C, then what do we have to do? We have to pretty much say temp.stir.push dash plus a C, I think, or it could be reference to C, plus A, and if it's none, then we have to, it's not temp.stir, sorry, it's temp underscore stir dot push hey with a dash. These need commas. Cannot add a reference to car to reference to string. We can only push one character at a time. String append slice. So Rust append stir to string. Oh, I think this one actually worked. Hold up. Let's try this again. Yeah, this is fine. All right, it's this. Does this work? That works. All right. What does this even take as an argument? That's taking a reference to a string. And plus, I guess, has to take in a string and then a reference to stir. So why can't I do let blah equal C as a reference to stir? Can I do this? No. I'll put it right here. All right, I'm just gonna do a bunch of pushes. So we're going to first push dash, and then we're going to push again, C, and then we're going to push stir, A. All right, that didn't work. We're gonna make a block, and we're just gonna do it one at a time. One at a time. Oh shit. Temp stir dot push. Temp stir dot push string. We're not gonna return it. All right. Does that work? Can I now move on with my life? All right, now we're going to print temp stir, because now I feel like my sanity has somewhat left me. Hello, hey. Amazing, hey. World way. I want to make this lowercase, so rust to lower. All right, to lowercase. Oh, whoops. To underscore lowercase. Oh God. Returns an iterator that yields the lowercase mapping of this car as one or more cars. Holy mackerel. Okay, can I make a stir of use lowercase? Of two lowercase? Get stir of two lowercase rust. Alright, there we go. Jeez. Alright, there we go. And am I going to uppercase this? Oh, I probably should. If it's convenient. I'm not going to worry about it too much. I'm also going to copy this over. In fact, I'm not going to worry about it. I'm going to put it right here. If I equals 0, then we are going to, oh man, say TempString dot push stir c dot to uppercase dot to string reference, else we simply push Bam. Now it should go. Oh God. What have we done? Alright, I've deemed it too complicated to do. And it's not worth it for me. Alright. So we got into 2b2. So if the first letter of the token is a vowel, oh my gosh, it's 9:30 already. If the first letter of the token is a vowel, then we simply append hey to token. Alright. Then we just gotta concatenate all these. And we're going to do that in this for loop. So we're going to let the mutable print v equal a collection of strings. Whoops. Neo. And then we're just going to, actually no, we just want to make it a string. Let's print stir equal string new. And we just concatenate plus equal t dot 0. Of course. We are going to borrow here. All right. And pretty much at the end of everything, we're going to say print stir plus equal temp c. What is it? A reference to temp c. Uh-oh. 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 We're gonna put it here. Oh, we need TempString, not TempC. Whoops. Bam. This is going to just print line, print stir. Alright, I think we did it. Oh my god, that took forever. Alright. Hello, amazing world. We're gonna say Rust. Things take forever in your language. I'm not gonna lie. And of course, this is not gonna go well. Oh man. Oh well. I may. Yeah. I'm going to ignore it because these are just corner cases, but the gist is there. Yeah. Ustre, hings te, ik te, in he, or ever fe, in he, your he, anguage lay, ie, may, ought ne, onage, ele. But at least it seemed, I hope this stream was better than the previous one because, you know, I did the whole pseudocode and then tried to, you know, label what I'm doing as I'm doing it. And hopefully you could follow along better than the previous one, because I think in the previous one I was all over the place. But I think as I'm going, as I'm doing this, I could be more descriptive of what I'm doing. I feel like I'm not explaining it well enough. Like what my thought process is as I'm doing it, but sometimes I just get lost in what I'm doing. I have to think, and when I'm thinking, I can't talk. That's the problem. But I should practice that because it is a really valuable skill to be able to communicate what you're thinking as you're thinking intently about something. And that's one of the reasons why I wanted to do this streaming channel, is to be able to practice my communication skills, especially with regards to technical topics like this. Anyway, that is Pig Latin in Rust. Like if you notice, well, okay, last time it took. All right, let's compare. Let's compare the. So it was an hour 40 versus what, 2 hours? Let's go to YouTube. Then we'll go to my videos, my channel. Alright, we've only really shaved off 10 minutes from doing mean, median, and mode. But I feel like this is a harder problem than mean, median, and mode too. So I feel like I'm getting more of the hang of it. So that's good. So next time we're going to do we're gonna do the next problem, really, which is why is this? Uh-oh, this is never centered. Anyway, next time, what are we gonna do? We're going to use a hash map and vectors to create a text interface to allow a user to add employee names to a department in a company. For example, add Sally to engineering or add Amir to sales. Then let the user retrieve a list of all people in a department or all people in the company by department sorted alphabetically. Oh, that's going to be kind of difficult. That's going to be longer than this. Because it's a text interface too. And hash map and vectors. So I feel like, is this going to be like a command line interface? Or should I just do it as reading a text file, right? I'm probably going to do it as read a text file, and then each line is going to be the command you want to do. So, for example, it's just going to be a text file where each line is a command, and the command can either be add or read. Right, and really, read is just going to be always of all people. Oh wait, read all people in a department or all people in the company by department, sorted alphabetically. So, okay. Alright, I'll think about it later. This is not the place to be thinking about it now, but really, all you gotta, I'm trying to understand the problem really. All you have to do is you have to read either all people, and they're sorted by department, so that means within each department, each person has to be listed alphabetically, and then everything, the whole company is sorted by department, and those departments have to be listed alphabetically. And you can either do that or just list people in a department. So there's really going to be two read commands. One of them is read department, and then you have to specify the department, which is, let's say, engineering sales, or you have to read all. So you can either say read engineering, read sales, or I'm going to say read department, engineering, sales, whatever, or you just do read all, and then you just format it the way it's telling you to format. All right, cool. All right. So, all right, that's that. I'm going to call it a wrap for today because this was a little too long. Just for, well, they're not simple. Well, they are simple, but they're not simple in Rust, you know, these problems. They're not, at least they're not trivial. I'm sure they're simple, but they're just not trivial, right? Oh well. Alright, I'm gonna end the stream. I hope you guys enjoyed. I had a little more fun this time than in the previous one. I think the, at least just by going with the stream, just feeling it with the stream, I think adding the pseudocode before I try to implement everything in the pseudocode helped. And even in the pseudocode, I had to beat off the track of what I expected I was going to do versus what I actually did. And I feel like as I learn more and more Rust, those two things are going to converge of what I'm actually doing and what I expected myself to do. But beyond that, I think it was a good addition to have the pseudocode beforehand so that way I have a map of what I want to do, how I want to implement things. And that way you can follow along as well, and then implement it later. So yeah, that's what I'm gonna do next time too. All right, I hope you all enjoyed it. I'm gonna see y'all later. Bye now.